Hello guys, welcome back to my YouTube channel. In this video, we are going to learn about an important topic that is exploratory data analysis. EDA is an essential step in the data analysis process. It involves analyzing and visualizing data set to summarize their main characteristics. EDA helps in understanding the data, identifying patterns, detecting anomalies, and generating hypotheses for further analysis. Okay, so first let's learn how to make bar graphs with overlay. What are bar graphs? Bar graphs or bar charts visually represent data using rectangular bars. Each bar's height corresponding to the value of the data. Overlaying allows you to compare multiple data sets on the same chart. And why do we need to use them? Overlaying provides a clear visual comparison of two data sets, highlighting trends, differences, and relationships. They are useful for understanding how different groups or categories relate to each other. Let's have a look at the sample code. Okay, first we are creating a sample data set in which we are creating category, group, and values. Now we are creating a data frame using pd.dataframe, and then we are creating cross tab using pd.crosstab. We are providing the groups which are category and group, and values will be these values 10, 12, 15, 14, 7, 9, 12, and 10. And we are providing aggregate function which is sum. Now we are trying to make a plot stack bar chart. In this, we are plotting the cross tab 01 dot plot, and we are plotting a bar chart. So we have given kind equal to bar, and we wanted stack the, you can provide the value false also here. And this is the figure size, and these are the colors. Okay, let's copy, paste, and move it to a Jupyter notebook. Okay, this is our sample data, and we are creating a data frame. Now let's try to run it. Okay, so now as you can see that we have generated the output. This is a stack bar chart. And if we give the value equal to false here, let's try it. What happens? एक एरर आ गई है, तो चलो उसको पढ़ के डीबग करने की कोशिश करते हैं एरर क्या है. नेम एरर, नेम फॉल्स इज नॉट डिफाइंड. चल ठीक है, एफ कैपिटल होगा इसका. नाउ विल अगेन रन इट. Okay, now as you can see it, previously we got stacked equal to true, then the bar charts were stacked. Now this time these are not stacked. Now let's move further. Analyzing relationships, contingency tables. So contingency tables, also known as cross-tabulation tables, display the frequency distribution of categorical data. They show how two or more variables are related. Contingency tables helps identify relationships and patterns between categorical variables, revealing insights about the co-occurrence of different categories within the data. Now let's look at the sample code. First, we are importing the pandas library as PD. Then we are creating a sample data frame using pd.dataframe, and there are two columns, gender and preference. Now we are creating the contingency table using pd.crosstab. We are giving columns gender and preference. Then we are printing the contingency table. Now let's copy and paste it. तो इसको अलग कर देता हूँ. Okay, so this is our sample data frame. Gender, male, female, and preference A, B, B, A, B. Preference are related to genders. This A to male, this A to female, and this B to female, like this. Now we are creating the contingency table using pd.crosstab. So we have to provide the column names which are gender and preference. Now we are printing the contingency table. Let's try to run it. Now you can see the output. We have got the contingency table as preference, gender male, male, AB. This is our contingency table. Okay, now let's move forward. Now we will learn how to make histograms with overlay. What are histograms? Histograms graphically represent the distribution of numerical data. The x-axis represents the data range and the y-axis show the frequency of occurrence. Why do we need to use overlay? Overlay histograms let you compare two or more distributions side by side, revealing similarities, differences, and potential relationships between the data sets. Now let's look at the sample example code. Here we are using matplotlib.pyplot SPLT to plot the histogram. And then we are generating the sample data using np.random.normal. Here we are generating two data sets. Now we will make the plot stacked histogram. Okay, so first we are using plot.figure, figure size, we are providing the figure size. Now plt.history, this is used to make the histogram. Now we are giving the data, the data 1 and data 2, the sample data sets which we have generated. Bins equal to 10 and stacked equal to true. Here also we will get the stacked histogram. Now these are the colors, edge color and the labels we are providing. And we can add titles and labels using plt dot title, x label, y label, and legend. Let's copy and paste it in our Jupyter notebook. Okay, these are our sample data sets, data one and data two, and this is the code for the plotting stack histogram. Now let's try to run it. Okay, now you can see we are getting a stacked histogram for data one and data two. You can also write false in place of true to see what happens. Okay, this was the expected output. Now let's move back to our PPT. Now let's see what is binning. Binning is the process of grouping continuous data into discrete intervals or bins. It simplifies data analysis by reducing the number of unique values. And why do we need to use binning? Binning can be used to create histogram, analyze distribution, and identify patterns in data that might be obscured by too many unique values. Now let's have a look at the sample code. We are first importing pandas as PD, then importing matplotlib pyplot SPLT for plotting the chart and sample data set. We can replace it with your, if you are having another data set, you can replace it with your data set. Now we are generating sample data set by two columns, age and response, and then we are creating a data frame with pd.data frame. Now we have to do binning. So we are making a new column age bind and using pd.cut, we will bin the columns. Now x is equal to bank train of age and the bins are bins basically it means we are we are dividing the data. For example, 0 से 27 के लिए कितने years हैं और 27 से 60 और 60 से greater less than 100. So in this way, we are dividing the data set and right equal to false. Now we will create a contingency table using cross tab and we will plot the cross tab using cross tab dot plot, which we have done earlier. So let's copy and paste. Okay, now you can see that this is our sample data set and here we are creating a data frame and here we are binning the ages and under 27, 27 to 60 and over 60. Now we are creating a cross tab and here we are plotting the check bar chart. Now let's try to run it. Okay, now you can see that we are getting this output under 27 yes कितने हैं no कितने हैं 27 to 60 में yes कितने हैं no कितने हैं and similarly for over 60 and if you don't want that text you can again use here false. So this is the desired output. Now let's move back. Okay, so what are the key takeaways and next steps? First, understanding. ED is crucial step in any data science project. It helps you understand your data, identify potential issues, and make informed decisions. Second, exploration. EDA is an iterative process. You will likely need to go back and explore your data in different ways as you learn more about it. Third is experimentation. Try different visualization and analysis techniques to see what works best for your data and your goals. I think that's it for now. मिलते हैं अगली वीडियो में. Till then, keep learning, keep exploring, and thank you for watching.